Hi, this is Kaylee, and let's talk about horizontal projectiles. And so what I mean by a horizontal projectile, I mean one that's initial velocity is strictly horizontal. There's no vertical part to its motion at the very beginning of its journey. And so just refresh your memory about a projectile. Projectile is something that moves in two dimensions, so it moves up and down and left and right, and the only force acting on it is gravity. So we're going to ignore air resistance, and it has no means to control its flight. So the path that a projectile takes is called a trajectory. And that trajectory will always be a parabola, or parabolic, I should say. But one thing that's really important with all projectiles, whether they're horizontal or fired at an angle, is that the horizontal motion and vertical motion do not interfere with each other. They're completely independent. And so we'll treat them separately when we solve the problem. Let's start off with this one. We've got a cannon on the edge of a cliff that's 150 meters tall. And the cannon is shot horizontally with a velocity of 200 meters per second for the cannonball. And we want to know where the cannonball is going to land. So this is a two-step process, a vertical part and a horizontal part. And where do you start off at? If I know the height that the object falls from, I'm going to start off with the vertical part. So for this one, vertically, gravity is acting. And the original velocity vertically is going to be zero because the velocity was completely horizontal. So it did not have a vertical velocity. So I'm going to use this. But I realize that vertically, the original velocity is zero, so that term cancels out. And so we get 150 equals 1/2 9.8 times t squared. And this way I can actually figure out the time it takes for it to fall. So 150 times 2 divided by 9.8 is 30.61, but I need to take the square root. And so it will fall for a time of 5.5, let's just say 3 seconds. Now during that time that it's falling, it's also moving sideways. But there's nothing affecting its velocity sideways. So remember, we're ignoring air resistance. So horizontally, we're just governed by this. The velocity in the x equals the distance in the x divided by time, because there's nothing pushing or pulling it sideways. And so the velocity in the x was 200. The dx, which is what we call range, we don't know, but it had a time of 5.53 seconds. Time's a scalar, so it can go in either the horizontal or the vertical parts of this because it's not dependent on direction. So my distance is 1,106 meters that it will travel before it hits the ground. Let's look at another problem. On this one, we've got an arrow being shot with a velocity of 80 meters per second, and it lands 48 meters from the archer, and we want to know the height. So we actually want to know this distance in the y. How far up was the arrow shot from? Well, I don't know any vertical parts to this problem. I know a horizontal velocity and a horizontal distance. So for this one, I'm actually going to start off with those two things. Remember, make sure you don't mix things up and don't put a vertical distance with a horizontal velocity. They don't match up. They have to make sure they match. So horizontally, Vx equals dx over t. Velocity in the x is 80. Distance is 48. And we got to find time. Super secret metric. That's why I call it when we switch these two. 48 over 80 gives me a time of 0.6 seconds. So it hit the ground in 0.6 seconds. So we need to figure out what height would it fall from for it to take 0.6 seconds to hit the ground. So vertically, again, we're going to use this equation, but we know there's no velocity in the vertical at the very beginning. So we're looking for the height it falls from, that will be our dy. Gravity's 9.8, and it fell for a time of 0.6 seconds, and that's squared. So square that times 9.8 divided by 2. We get that the height it was launched from was 1.76 meters. All right, one last example. On this one, we've got a rock thrown horizontally from a height of 5 meters. It lands 18 meters away. What's the velocity of the rock? Oh, well, we've got a vertical distance and a horizontal distance. Again, if I have the vertical part, I know that gravity is pulling it down. So for that part, I'm going to use this. But again, I know that part cancels out. So sometimes you don't even have to write that. It fell from 5 meters. Gravity's 9.8. And we got to figure out t. So 5 times 2 divided by 9.8 gives me a t squared of 1.02. I'll take the square root, and my time is going to be 1.01 seconds. Now to figure out the velocity, well, that's a horizontal thing, and horizontally we've been using this because there's nothing that's going to affect it horizontally, so it's going to move at a constant speed. So we're looking for Vx. We know dx is 18, and the time was 1.01. Well, 18 divided by 1.01 gives me my horizontal velocity of 17.82 meters per second. Those are the 3 basic questions that can be asked about horizontal projectile problems. Thank you, and I'll talk to you later in another video. Goodbye.